In addition to divergent plate boundaries, let me stop the animation. In addition to divergent plate boundaries, there are also convergent plate boundaries. At a convergent plate boundary, two plates come together. There's a convergent plate boundary off the coast of Washington State, Oregon State, Northern California. So there is one just offshore from our own country, the Pacific Northwest of our own country. There are other convergent plate boundaries off the coast of southern Mexico, Central America, South America is a place you find a convergent plate boundary. Part of the Caribbean has a convergent plate boundary in it. India and Eurasia, where those two have come together, there's a convergent plate boundary. And there are others in other parts of the world. On this map, there are lines with triangles along them. There are three major types of convergent plate boundaries. At these convergent plate boundaries, two plates come together. Now I'm going to start by talking about the ocean-continent kind of convergent plate boundary that's depicted here. At an ocean-continent convergent plate boundary, a plate that has oceanic lithosphere on it, this plate right here, dives down, comes together with, and dives down below a plate that has continental lithosphere on it. The plate with the oceanic lithosphere is this one on this animation. The plate with the continental lithosphere is this one on the animation. Now the animation is a little busy. You don't just have a convergent plate boundary on this animation. You do also have a divergent plate boundary. The convergent plate boundary is really close to shore. Here's the shoreline right here. We've got continental lithosphere on the right, oceanic lithosphere on the left, the convergent plate boundary in between. And then, even farther offshore, there's the divergent plate boundary shown here. I already did divergent plate boundary, so I'm just pointing it out to you so you're not confused. We're going to kind of take the divergent plate boundary, set it aside, already did it. Okay, convergent plate boundary over here, as I said, a plate with oceanic lithosphere on it, diving below the plate that has the continental lithosphere on it. This process whereby one plate goes down underneath another plate is called subduction. And near the subduction zone, the place where one plate is going down underneath another, volcanoes grow. At an ocean-continent plate boundary, these volcanoes are said to be part of a continental volcanic arc. Cascade Range in our own Pacific Northwest of the United States. Washington State, Oregon, Northern California, Cascade Range, mighty volcanoes, St. Helens, Rainier, Hood, Baker, the list goes on. Those are part of a continental volcanic arc formed near a subduction zone, formed along this convergent plate boundary, ocean-continent convergent plate boundary. Now, right where the oceanic lithosphere dives down beneath the continental lithosphere, right here, you have an oceanic trench. That's a deep spot in the ocean. The trenches are better developed at some convergent plate boundaries than at others. They're better developed at some of these ocean-continent convergent plate boundaries than at others. But in many of them, you do find these trenches, these deep spots in the ocean where one plate goes down underneath another plate. ocean-continent convergent plate boundary. So the second of the three major categories of plate boundaries, convergent, three subtypes. This is ocean-continent. Another subtype is the ocean-ocean convergent plate boundary. We've still got two plates coming together, as you can see, with these two red arrows, and you still make volcanoes. You still have volcanoes, and there are volcanic islands. It is still a volcanic arc. It's not a continental volcanic arc because it's not on a continent. We've just got two plates, both having oceanic lithosphere. But you do have volcanoes. You do have a volcanic arc. Earthquake activity, those are those little explosions. At every kind of convergent plate boundary, you have the earthquakes. As I was saying, plate boundaries and earthquakes, they really go hand in hand. Make a map of the world's earthquakes, except in a few places, you're also mapping out the plate boundaries. You've got earthquake activity along the convergent plate boundary. You have volcanic activity feeding this volcanic arc. Now, this kind of convergent plate boundary, ocean-ocean, it is associated with some of the deepest places on the planet. I already mentioned the trenches that you find where two plates come together and subduction happens. One dives into the other. The Marianas Trench, the Challenger Deep, is the specific spot within the trench. Challenger Deep within the Marianas Trench, deepest place in all the world's oceans, that's at an ocean-ocean convergent plate boundary. Plate tectonics explains many things. Among these things, the extremes in elevation on our planet, and here you have one of those extremes. Deepest spot in all the world's oceans, it's at an ocean-ocean convergent plate boundary. There's one more kind of convergent plate boundary left to examine, and that's the continent-continent convergent plate boundary. Okay, so it's three subtypes of convergent plate boundary. Continent-continent. Let's look at that. The big example of a continent-continent convergent plate boundary in the world today is where India meets the rest of Eurasia. India protrudes out of Eurasia into the Indian Ocean, but it was not always so. Long, long ago, India was an island subcontinent, something like Australia today. And over time, India, that island subcontinent, moved from its present position, from where it was off the shore of Eurasia, and it collided with Eurasia, raising the Himalayas. Plate tectonics explains many things, including extremes in elevation. Highest point on the planet, elevation relative to sea level, Mount Everest in the Himalayas. Highest point on the planet is at a convergent plate boundary. It's at a continent-continent convergent plate boundary. One of these plate boundaries where two plates having continental lithosphere have come together, collided, raising a mighty mountain range, the Himalaya. And kind of showing that animation to you again, India, originally an island, subcontinent, something like Australia, thanks to convergence, India colliding with Eurasia, raising a mighty mountain range. The Himalaya includes the highest point on planet Earth, as measured relative to sea level. Mount Everest. So that's the third of the three subtypes of convergent plate boundaries. We've got ocean-continent, ocean-ocean, and continent-continent, the third subtype shown here. Okay, we're done with those subtypes of convergent plate boundaries. Let's go back to the major categories. Divergent, convergent, transform. Let's check out transform. First, let's check out the map of the world again. Where are these things? Okay, here's transform. On the right-hand side of this map of the world, we've got two plates sliding past one another. Not a lot of vertical motion. Not a lot of up and down. They're just sliding past one another. Transform plate boundary. Within our own country, there is a transform plate boundary. Southern California, Central California, running up through the San Francisco Bay Area. Famous transform plate boundary. Principal fault at that boundary is the San Andreas Fault. So, we've got one of these things, a transform plate boundary within our own country. Other transform plate boundaries, there's one in the Caribbean to our south. In part of the Caribbean, there's a convergent boundary. It's over here in the eastern part of the Caribbean. But in another part of the Caribbean, like near Haiti, for example, you have a transform plate boundary. And then in other parts of the world, there are other places where there are transform plate boundaries as well. Two plates sliding past one another, not a lot of vertical motion between the two. In an animation, transform plate boundary, two plates sliding past one another. There they go, two plates sliding past one another. Not a lot of vertical motion between the two. You do see earthquakes, the little explosions in the animation. You do not see something else. What is missing? What is not in this picture? Well, what's missing is volcanic activity. You do have volcanic activity at divergent plate boundaries. You have volcanic activity near subduction zones. There's little to no volcanic activity along transform plate boundaries. They are almost completely devoid of volcanic activity. And with that, I am done telling you about the three different kinds of plate boundaries and answering a whole lot of the study questions to boot. Divergent, convergent, transform, three kinds of plate boundaries, three major categories, and then the convergent plate boundaries, there are those three subtypes.